Okay, so I need to give you some tools for solving rando triangles. These are not necessarily right triangles. Okay, so if they're not right triangles, what tools are forbidden me?
30, 60, 90, and 45, 45, 90.
Yeah, my two reference triangles, right, the 30, 60, 90 and the 45, 45, 90 are not going to help me in this
Out the window.
because I haven't got right triangles in general. If you do have a right triangle, you have those tools at your disposal, right?
Yeah.
What other tools am I missing because I don't have a right triangle?
Pythagorean theorem.
Yeah, I also don't have the Pythagorean theorem. So I have no reference triangles. I have no Pythagorean theorem. What else am I short? What other tool works only in right triangles?
I feel like you should know this.
Side angle side, side, like those things.
Hmm. Those are the things I'm gonna have.
Yeah, that makes sense.
Sine over side.
No, that's
Sine
the
of
thing I'm
one-
gonna have too.
What are you
Angle
asking?
side, side.
I'm asking, what else am I missing? So the other thing you're missing is you can't use the trig functions in here,
Yeah.
Oh, yeah.
Yeah.
right? Because trig functions, is,
Yeah.
like sine of 53 degrees is something that your calculator knows, right?
Because it's a standard triangle.
That's in a right triangle,
Right, standard triangle.
right? So
But I remember doing in trig class that we do something like log cosines or something.
yeah, so we're gonna learn some tools to overcome these barriers, but just the plain trig functions like SOHCAHTOA,
Yeah.
Oh.
right, is not going to be at your disposal because there's not necessarily a longest side in these cases.
Sure.
You guys see that? Okay, so
So that would be a tool. No. For
It would-
non-right triangles.
yeah, so in non-right triangles, I don't have these.
Right. Okay.
In right triangles, these are the tools that I like really reach for, right?
Right. Okay.
Cool. So these ones are right triangle tools. Those are not allowed in this space. So instead, the things I have, you guys seem to know some of. Somebody mentioned a law of,
Cosine.
yeah, there's a law of cosines. What's the other one?
Law of sine.
Law of sines is another of these. And then I like Levi's. What did you say earlier, Levi?
Side angle side.
Yeah, you said something like, oh, there's like side angle side things and
Side.
angle, side, angle,
Angle, angle.
and angle, angle,
Side,
angle.
side, side. But not angle side, side, generally, unless you have like log cosines.
I don't care. There's this one.
Ash.
I just remember in high school there was no ass in class, but now we've learned.
Yeah, so some people do this yeah, whatever.
Yeah.
At any rate, there's a whole bunch of classifications. Some of these, it should be noted, are solvable. Some of them are not solvable, right? Some of these yield a unique triangle. Some of them don't. Some of them yield two triangles.
Right. That's.
You guys remember those tricks?
Yeah, definitely.
So it is worth maybe thinking about these. I'm not going to teach you like a list to memorize. I'm just going to show you how to figure out which ones are which. You guys cool with that? You wanna-
Like how to
Maybe let's start with this.
like
okay?
how to identify
Yeah.
which one to use. Okay.
Okay, so in a case where you had something like this, here's a triangle, right? Say that this triangle is 37 degrees, 104 degrees, and unknown. If you know none of the sides,
You know.
what case are you in here?
You know that all angles
Angle,
have.
angle.
Angle.
Yeah, this seems initially like you're an angle case, right?
But not angle.
But my claim is once you know two of the angles,
You know the third.
you know the third one, right?
Because don't they all have to add to 180 degrees?
So keep in mind that's true in triangles, right? That's not true in squares.
Of course not.
Right?
Twice as much.
So sum of triangle angles is either pi or 180. I don't care how you think about this particularly.
Well, I mean,
Okay. So that's a tool you have at your disposal, right? What's that?
Wouldn't you know all the angles in the square?
he doesn't listen by the way.
Yeah, in a square I know they're all 90, right? But they don't add up to 180 was my point.
I was actually rolling through.
Also, keep in mind that this is true for triangles on flat surfaces. You guys know this? This thing about the sum of angles in a triangle add up to 180 degrees is true on flat surfaces.
Well,
Wait,
It's-
what? Say it again.
What about
what you have up here, and it doesn't add up to 180. Yes.
So this is true on flat surfaces.
What does it add up to in like
3D?
pyramids wise?
A pyramid is not strictly speaking a surface. I don't know what a triangle looks like.
Oh, do you mean it on a curved surface?
Yeah, I mean on a bent surface. Like
Mm-hmm.
on the surface of a sphere, for instance, like in surveying class, right? If you make your triangles big enough in surveying class, you can end up with weird stuff. For instance, a triangle you might end up with in surveying class is this one really kind of dorky one, which is you have 3 people standing at various points around the globe, right? And then let's call those people this guy and sheep.
Oh, I missed the sheet. Oh my goodness.
I can draw them. That's really principally my
I
essay.
would disagree.
I remember.
You know what? That hurts my feelings. This is supposed to be a safe space.
I
remember
Okay?
the
put
first
on
time.
this for my
Looks
dog.
like a cloud.
And somehow you can draw that
At any
shape.
rate, hush. I want you to envision a guy and a sheep and a house all situated along the equator,
Yeah.
right?
Yeah.
From the guy to the sheep is a side of a triangle, yes?
Mm-hmm.
From the house to the guy is another side of the triangle.
So true.
And from the sheep to the house is yet another side.
You have to travel through the earth.
No, it just
Oh.
goes around the back.
Oh wow, that's not. That's like. I guess.
You guys see this is a triangle, right?
I see what you're trying to say. Yeah.
You're triangling to say.
If the equator is identical, wouldn't that just be like a circle?
Yeah, the equator is a circle, sure. But the surface is bent, right? So any triangle you draw on it's going to be a little bit bent anyhow. This is just kind of the most bent triangle you can draw.
Do they have to use that, like take that into account when they like do triangulation for earthquakes and stuff?
Yeah, this and quite a bit more. Yeah, triangulation for earthquakes is actually extremely hard. But this triangle, right, has 3 angles in it. What are the angles in this triangle?
They all add up to 360.
No one.
They're all 180 degrees, right? You guys see that? Like, this is one of the angles, and that's one of the angles, and that's one of the angles, right?
Oh my gosh.
So it's an inside-out triangle.
You guys see that? Well, it doesn't matter. Draw it on the other side. But at any rate, the sum of angles in that triangle are not 180 degrees
540.
because it's not on a flat surface.
That's a real
You guys
trick.
see that?
I don't like that.
Yeah, like disturbs my definition of a triangle.
Yeah.
Can we just forget that this ever
Morphed into
happened?
something that's completely
No,
different.
Yes, we can forget that this ever happened.
Okay. I like a sheep, but.
Okay,
this
you
is-
may forget that this ever happened as long as you promise to only do triangles on flat surfaces.
Oh yeah.
Gwen, I expect you to believe that the earth is flat from now on.
Forestry too.
Are you?
Don't sing me out.
Okay. The 2 of you, I expect to either believe that the earth is flat or stop playing with triangles once they get a mile on a side or something. You could probably get away with 8 miles or something. Or they get away.
Well.
Don't survey anything bigger than a county.
Ew, what's that?
Just watch me try not to do that.
Okay.
It's my pastime.
Sweet.
All right. So,
As
what
long
is my
as-
other angle in this
no
segment?
hesitation.
It's 104 minus 37, or 180 minus 104 minus 37.
Your nose.
Okay, so I would do 180 minus 104 minus 37.
Sorry, no, it's 104. It looks like 184. You should change that.
Better?
And your 180, that's like 110 to the sub-zero.
Oh my god.
Look,
So whiny. At any rate, you get
I don't know, I haven't even.
equals number. I don't even care what.
Yeah,
Well, it equals 76.
no.
Okay. For real?
Well, I don't, it's 76 plus 4.
No, it's not 76.
76 plus 4 is 80.
30,
Oh, you put your minus
39.
37. I did not looking.
39.
I am crazy.
Okay, so we got 39 degrees, or whatever.
Think
My
about
question is, do you know this triangle uniquely given these three angles?
You don't know the sides.
it. Yeah, it's a
Just
very
have
specific
some
triangle.
sides to know.
Yeah, you don't know anything about the sides at all, right? I could take that triangle and scale it up, right?
Mhm.
Or scale it way down, and it would be the exact same information. You guys see that?
Yeah.
So, angle, angle, angle determines how many triangles? Yeah.
All triangles.
That determines not all triangles,
I mean,
but
All
all the
nine-
triangles with those angles
all
at any
non-
scale.
All non-right triangles. Right?
What?
All non-right triangles?
No. That one specifically.
Just that one specifically?
That one specifically. Those three angles at any size.
Oh.
You guys see that?
Yeah.
Like if I know that the three angles are 37, 39, and 104, I know something about this triangle. If I knew one of the sides, I could get all of the sides.
Are those gonna come up enough to where we're gonna need to know that?
Yeah.
Like those exact angles?
No, not those ones. But you might, it will happen that you sometimes know all three angles in a triangle, but none of the sides.
Oh, okay.
Right? This happens when you're out surveying and you shoot the angles and your buddy forgets to write down the distance measurement.
Yeah, Clint.
Exactly. Then what do you have to do? Because Clint screwed up, you gotta send his ass back out there to measure one of the sides, right? Because you can't figure this out, right? One of the tools that we use this for is like you were surveying in the rain, right?
Yeah.
And you got your book smudged. Sometimes you can get away with figuring out what the missing piece of information
Our
is.
books don't smudge though, we use 4H pencils. It's a reason.
Clint dropped it between the seats and then ran the seat forward and backwards on it a bunch. It's all jacked up, okay?
Ulterior motives.
So, if you have angle, 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 there are infinitely many possibilities for what your triangle looks like. You must go back to the field and remeasure. See
So
that?
we're trying to narrow down the triangle.
So right now I'm just kind of demonstrating how these things work. So if you had, say, let me pick angle, side angle. So that's, I know this distance. So this one I know. This distance I know. This angle I also know. So for illustrative purposes. Those don't look like they're the same, do they?
Just look at that.
Oh,
More or less.
they're just not supposed to be the same.
Not supposed to be so.
Okay, so in your surveying, you found an angle and another angle and the side length in between them. Have you done a good job? Are you able to figure out the rest of this triangle?
Angle, side angle, yeah.
Seems like, right? If I like kind of drew this on the floor, right? I could measure those two angles and then we could walk this side out and we could walk this side out.
It would be very specific.
And then I'm going to know this one. How am I going to get that? That third angle.
Because you already have two, so you can just.
Yeah, I already have two, so I take 180, subtract the two I know, that'll get me this third one. And then these two, it seems like they have to be uniquely determined. Right, there's no other option there. That's cool with us? So, angle, side angle makes how many triangles? One.
It only deals with.
If I tell you that
Yeah.
you have an angle of 37 degrees, a side of 10, and an angle of 48 degrees, there's only one triangle like that. You can figure out what that triangle is by doing a procedure like this.
Yeah, it only applies to one type of triangle.
Yeah, there's only going to be one triangle for that. You guys see that? So, a similar but slightly different case would be, you know one angle and a side length and another side length.
Oh, is that a right triangle?
Oh, I did not intend to make this quite a right triangle. Sorry. Let me make that substantially bigger. You guys see this? So which case am I in?
Angle side side.
Nice. This is a angle side-side case. Cool. Okay, so how would you go about trying to figure out the rest of this triangle?
Well, you see.
Like, I don't know this angle, right?
Right, so it could be like.
But I do know this one.
Right.
So I could trace this out a ways, right? I could just go,
Sure. Yeah.
right?
Mhm.
And then I can take my ruler. Right? And go, okay, so if I go up this far, let me pivot that. So let me mark this. So if I pivot this, see there's one of my triangles. Like that's a possible triangle like this.
Wait, so-
You guys with me on that?
Wait, so that's arbitrary. What you just did.
So it's the same length as this, right? It's
Yeah.
known.
Yeah, yeah.
So I just swung it around until I hit the angle.
Right, makes sense.
Is this the only triangle I can get with in this case?
No.
Why?
Because if you erase your big fat line that you drew, the dotted one, then you could swing it to make it an acute angle.
Oh, I could keep swinging this
Right
around.
there, yeah.
See that one?
Oh, maybe.
You're right.
So then now you have a right
I just like the little
triangle.
triangle like that.
No, it's not necessarily right. But you see there were two options here.
Right. So how do you?
So how do I pick?
How do you compensate? Well, you do log something.
What?
Oh, you can't choose.
Yeah, you can't choose. They both work, right? They both have the angle that I specified and the two sides.
It's just crazy talk.
So triangles are a little funny, right? In these situations, right? You might end up with one answer in a case like angle side angle. You might end up with infinitely many answers, like an angle, angle, angle. Or you might end up with two answers, like this one, except that I've lied to you.
Great.
I just wrote it down.
So, how did I just lie to you about this thing?
There's only one.
I picked kind of a special length there. You guys see that? So what if instead of what if I had, instead of a long length like this, for instance, just to give some examples for numbers, what if I said this was 43 degrees and Clint wrote down that this was 10, and then what if he said, yeah, and actually that third side was 2? What would 2 look like?
It would be like a fifth of that time.
Yeah, it'd be like a fifth of that. So it'd be something like this, right?
No, you only have
So
to
the
someone
angle
just
in
swing.
the sides has to be obtuse or something?
Well, basically this side has to be long enough to hit that angle.
Oh, so we have to.
You guys
use-
see that?
Do we have? To
So
use-
sometimes this doesn't, like in this case where I have 43 degrees and then a side length of 10 and then a side length of 2,
Right, that's what I'm
there's no triangle like this.
Makes sense.
Yeah.
Or there's 2 triangles if that side's long enough. Or
Or one.
Still right to it.
it's possible that you get it just perfect and there's only one.
So is it when that length 10 right there would be something like length 2, and then, or like 5, say, and then the other one is length like 3, whatever, so just.
How about
only
it would
has-
be when this is perpendicular?
Right, that makes sense.
Which is,
The right
Which
triangle.
would be a right triangle.
Yeah. Yeah. Yes.
Perpendicular.
Perpendicular up there. Not right down here, but perpendicular up there.
But up there, anywhere it's right.
Wait, so then it's right.
You guys-
triangle.
Yeah.
it's right triangle.
You were right. Sorry.
Oh, that's right.
So, what I want you to think about with that kind of second side is that you could make a circle around it, right? And sometimes that's going to hit this known angle no times, or maybe one time when it's perfectly tangent, or twice. It's also possible that it could be really big and hit only once. See that? I almost did it with the first one I drew.
Almost.
Right, because if it was, say, this long, right, it's not going to hit down here because this doesn't mean anything in your triangle, right? So the only spot it would hit is the one way here. Let's go that. Okay, so this is basically triangle typing. And what I want you to know is that when you look at a triangle type, it's worth thinking about how many answers are there going to be like that before you start. And you can memorize this list. I'm sure this list is in your textbook with like a certain number of triangles that might result from each of these. I would prefer if you just kind of drew a picture and thought about it for a second because it's not that hard. Questions?